Welcome to the DevGraph Tech Talk series. I'm your host, Aaron. Today, I'm going to show you how to deploy your first container on AWS Elastic Kubernetes Service, EKS. Disclaimer, I'm also going to do a head-to-head comparison with Engine Yard Kontainers to show you how it can be made a little bit easier. Okay, so I have a Ruby on Rails application. It's a project in GitHub. It's a simple web application, a game where you try to guess colors. It's called Mastermind. You get feedback until you guess it right. So I just want to run this application on the cloud in a container. That's what I want to do. Now, I'm obliged to show you a marketing diagram, which has some kind of like Venn diagram or triangle. So that's this here. At the bottom, you have AWS. So Elastic Kubernetes Service is really an infrastructure as a service. These are powerful primitives. They power much of the internet. Engine Yard Kontainers sits on top of that. Platform as a service, it's going to make it much easier so you can do what you actually care about, and that's your application on the top. All right, let's do a head-to-head Engine Yard matchup. On the left, we have the 1979 Porsche 928, beautiful vehicle. On the right, the 63 Corvette Stingray, one of my favorites. I think we actually have a live shot now of both of the cars in the pit getting ready for today's event. Okay, I think we are ready. The race is about to start. Let's go over to that footage. All right, here they come. The cars are coming into the final turn. They're neck and neck. This is going to be a close race. Oh, here they come, and the Stingray pulls it out. That is incredible. Oh, hold on a second. I'm getting word from my producer. This is the wrong head-to-head Engine Yard matchup that I'm showing you. Oh, yeah. Oh, now I see it. Folks, I'm really sorry. I was showing you the wrong head-to-head matchup. Please do forgive me. Okay. So let's start this over again. Let's put on the brakes. Let's put it in reverse. And let's see if we can keep on trucking here. Okay, the head-to-head Engine Yard matchup. On the left-hand side, this is the process that I went through to deploy that container on EKS that I was talking about. That's quite a few steps, right? I'm going to walk you through each one of them, though, have no fear. On the right-hand side is the EYK process. Pretty simple. I'll show you that as well. So when we go to look at the AWS container page, there's a ton of primitives, and we always end up needing to use the registry. That's where our container images live. In a previous video I did, we looked at using ECS running on Fargate. So to mix it up, today we're going to do EKS on EC2. All right, so this is the architecture diagram that AWS offers. Basically, what you can take from this is on the top half, you have the control plane. This is managed by the cloud provider, your infrastructure as a service. You use the kubectl CLI to set up and control things. On the bottom is a view of your worker nodes. I prefer a little bit simpler view since we're doing these competitions and head-to-head matchups. So here's a little bit simpler view of your Kubernetes cluster. You use EKS-CTL to actually create that cluster, and it's comprised of a number of nodes. Now, not surprisingly, in this case, these nodes are EC2 instances. After that, you do two different deployments. So the first one is you take your container and you deploy it. The pods are the smallest unit of deployment. And so the replica set, I'm going to say that I want to have 2 for redundancy. And so there's going to be a pod on each of my nodes. As a second step, then, we will deploy the service, which is a load balancer. So prior to deploying a service, our pods are just sitting there on the network inside of my cluster. They've actually got an overlay network that you deal with, so it's got its own DNS entries and its own networking proxy. Once we get that service, which is actually also a load balance service as well, then we can actually connect to it from the internet. Okay, so what do we have to do? Well, these are the steps that we're going to go through. We're going to create that container image because the first thing is all I have is a project in GitHub. I don't even have a container image, so I need to do that first. So I happen to have a Mac. You may have Windows or something else. So you install Docker Desktop. I did that on my Mac. I cloned the project. I created that Docker image. And then this is important, test it locally. That'll save you a lot of time because by the time you upload and run these things, if it doesn't work, you want to find that out sooner than later. Okay, we're going to store the container image in the registry. So you can actually, it's kind of nice, you can connect the Docker CLI to connect automatically to ECR. So we'll do that and we'll create a repository so we have somewhere to put it, tag the image so that we can then push it to the registry. All right, now we're actually getting to the EKS part. So we're going to install those CLIs. There's actually 2 of them there. Then we're going to create that cluster that we just showed, do our 2 deployments, and then finally test and make sure this whole thing works. Okay, let's go dig into this. We browse over to docker.com and grab the Mac install, drag that into our applications folder, and now we've got Docker running on our desktop. We need to get our project, and the branch that we want is the Docker app branch. So I'll fetch that and go ahead and switch over to it. Again, it's just a simple Rails app. I'm going to show you the Docker file. It's got a Ruby base image, and then it's pretty simple. It installs Node.js, sets up the gem file of the version we want, does a database migration, and is running on port 3000. Really not much else to it. The next step then is to build our container image using the Docker build, and we'll give it the mastermind 1.0 tag. We can go and see that on our Docker dashboard. There's the image. It's not in use yet, but there it is. Now the next thing to do is make sure that it works locally. So we can run it and we can map port 80 on our desktop to the container port 3000. Now you can see it is in use, and there is our running container. If we browse, we can see our game. It's simple mastermind game. We're guessing red, green, blue, yellow. So we'll make a few guesses, get some feedback, see that we got 3 out of the 4 right, set the last one to yellow, and there we go. There's our correct guess. Now we can store this container image in the repository. We'll use ECR get login passwords so Docker CLI can connect to it. We need to create the repository first. Here's the API to do that. We'll call it Darren's ECR repo. There's all the great info about it. So now we can tag the image for that repo, version 1.0, and then do a Docker push using that label. This takes a little while, so we'll go ahead and fast forward, and there we go. We're all done. On to the third and final phase. We use Brew to install the Weaveworks, and AWS partnered on these CLIs. So these commands come from the AWS documentation. We first do that, and then we can Brew install the EKS CTL. So that takes a little time also. We'll let that install. Actually, we'll go ahead and fast forward. This is video. We can do it, right? Yeah, so let's just make sure that we've got it installed correctly. We'll do EKS CTL version, and that's the version we're running. Great. So everything seems good there. Now what we can do, really the only thing you use EKS CTL for the most part, is create the cluster. And you give it a name, Darren Kubernetes cluster. And this does take a while. This takes like 10 to 15 minutes, but it's doing a lot of work. It's creating the node groups for you, the auto scaling group, the load balancer. We've got our infrastructure set up. The control plane is registered under our cluster name, and we've got some worker nodes, but there's really nothing much on them. So at this point, we're going to switch over to use the kubectl CLI. And when you create and do deployments, everything is based on YAML files. So here is the mastermind YAML file. Let's walk through this for a second. So the namespace, we're going to be in the default namespace, but you can create multiple and essentially the same physical infrastructure. You can logically divide it into different service spaces. And so the commands, you can specify the namespace. I'm not going to do that. Everything's going to be out of the default today, but just know that you are able to do that. I'm specifying that I want 2 replicas, and then the selectors are important. So these are labels that do string matches. You'll see the importance of this a little bit later. That's how things get tied together. And then in the spec, I reference the URL of the container image that we just stored in ECR, and also call out that it's exposing port 3000. That's where our Rails app is listening. So you'll notice then that kubectl only lists one service, and that is the Kubernetes service itself. Remember, at this point, we just have those pods. They're not even accessible externally. They're only available internally. The next step then is to create the service that exposes them. Let's look at the load balancer YAML. Important, it uses the selector mastermind, and that's to get the pods that we just created. And then it maps external port 80 to the container's port 3000. We run that create. So now when we do the service, we see that there are 2. There's the Kubernetes service and our mastermind service, which has an external address, and that's our load balancer. So I'm just going to grab this external IP address, copy that into the browser, and there we go. There's our game. So now we have deployed our container onto EKS. Let's compare that process now to EYK. We still need to clone our project, but from here the process is super simple. You create a cluster, which is a geographic region, and a VPC that your apps run in. Create your application, which maps to your Git repo, and then do a Git push. That's literally all you have to do. So let's take a quick look. I'm sitting here in a directory where I've already cloned my project, and I can show you, I did have to make one change. So for the Docker file, the command is essentially ignored because the processes are going to be defined in a proc file. Also, the port's on 5000, so just so I don't get confused. And then here's the proc file. It's the exact same thing. We just moved that one statement from the Docker file command to our proc file. We've only got one component. You could have many components here. So I can create my application by doing EYK create and then the application name. So I will call this Docker game. And what this does is it maps that project and creates a git remote target. So now I've got an EYK. So now all I have to do is do git push EYK, and I am on a branch here. So let me show you that. I'm on the Docker app branch. So we'll specify that. So git push EYK, Docker app, and away we go. Right now, EYK is building a fully managed infrastructure for me on AWS in my own private account, nice and secure. There you go. Now my application was deployed. I can use EYK open directly from this directory. That's going to open my browser, go to my web app, and hopefully we'll see our game deployed. And there it is. That was pretty simple, my friends. Okay, so we've shown how you can deploy your containerized application natively on Elastic Kubernetes Service and then also on Engine Yard. So AWS is great, extremely powerful primitives, but if you don't have an army of DevOps engineers, check out EYK. It's going to deploy your applications on a fully managed platform. We have best-in-class 24/7 support. All of this infrastructure on the left that you see is going to be completely taken care of for you. If you're in a very agile environment, you want to focus on your application, provide value to your customers, check us out, engineyard.com. And thanks for joining us on the DevGraph Tech Talk series. I'm your host, Aaron. Next time, we won't mix up the engine yards that we're going to. We'll get it right. We'll see you then.